don't forget it. Write the rule. Force times its arm equal resistance times its arm. Force 100. Its arm 25 equal resistance 500. Its arm, yes, we want this. So we want what? Resistance arm. Resistance arm equal 100 times 25 divided by 500 equal 5. 5 what? We're talking about the arm. So it will be centimeter. Why we write the centimeter? Because the force arm is unit with centimeter. If the unit here meter, we write here meter. If this is centimeter, we write here centimeter. We can find example on these problems at your booklet, page number 5, and they will be your homework. Okay. We have another part in this lesson, which is types of levers. Yes, I know that we are talking about this part later, but here we want to know which of these levers used to save effort or used to increase the force that we are talking about it in the start of our lesson. We can use all these classes to save effort? Of course, no. So we can use what? We can use, we have to study the first, each type or each class, and know which of them save effort and which doesn't. But before we start, we have to know that this is MP. Very important. The lever save effort when we find that resistance R larger than or longer than resistance arm. So when we find that the force arm longer than resistance arm, we can say it saving effort. But if they are equal or in the opposite, where resistance arm is longer than force arm, this is wrong. Doesn't save effort. What's meant by save effort at the first? By doing a small force, we can get high resistance. How? By using these pliers, we can't pull the nail with our hand. We can't pull it with our hand. So we use what? We use pliers. This plier, by a small effort from this side, we can pull this nail. So by using a small effort, we get a high resistance force. This has happened when the force arm longer than resistance arm. Here the fulcrum, the resistance, so this is the resistance arm. And this is force, so it will be force arm. So when the force arm longer than resistance arm, it's a save effort. Okay. What is the type of this lever? Yes, fulcrum between resistance and effort force. Sure, it is from the first class levers. Let's continue. In the first class lever, we have 3 cases, A, B, and C. When we're talking about A, we find that fulcrum between effort force and the resistance. But the distance between effort force and fulcrum and resistance, they are equal. So we have that effort force arm equal resistance arm. So save effort or not saving effort? Doesn't. Why doesn't? Because we need that force arm longer than resistance arm to save effort. But here they are equal. So it doesn't save effort. Okay. B. Here, first class or second class or third class, we find that the fulcrum in the middle. So they were not equal. But we need to know that this is first class. Okay, we agree with that. But the distance between effort force and fulcrum is longer than resistance and fulcrum. Yes. So here we find that resistance arm is less than force arm, or force arm longer than resistance arm. So we have here the condition. So it will save effort or conserve effort. Okay. So we have here a case. a case from first class. What about third class? What about third cases? C. We find that the fulcrum between effort, force, and resistance. So it will be also the first class lever. But here, the resistance arm less than force arm. Save effort? Of course not. When the resistance arm longer than force arm, it doesn't save effort. So we have here in the first class lever 3 cases, A and B and C. One save effort and the others doesn't save. So we can say the first class lever sometimes save effort. Sometimes save effort. Okay. Let's move to another class. Second class, we find the R between F and O. Resistance between effort, force, and fulcrum. So we find that where is the resistance arm? Yes, here is the resistance arm. Very small. Where is the effort, force arm? Here? This distance? No. We have to catch with fulcrum. But we have here resistance. Never mind. We need all distance, the whole distance between effort, force, and fulcrum. So which is longer? We find here the longer part is the effort, force arm. And always. So we find that force arm longer than resistance arm. So we say that it's always save effort. And didn't have cases like in the first class, but it's only one case. It's very simple and easy. I like second class. So what are the third class? The third class, we find that effort, force between resistance and fulcrum. Where is the effort, force arm? Here. This is the effort, force arm. Where is the resistance arm? Yes, all this distance. So we find that always the resistance arm longer than effort, force arm. So resistance arm longer than effort, force arm. So it always doesn't save effort. Like what? Like here in the tweezers. We say that it is a third class lever. We can't use it in making a huge effort or save a huge effort. But it's used for another purpose, which is, yes, accuracy in performance. To pick up a very small object with high accuracy. So maybe it doesn't use in saving effort, but it has many importance in other side. This is the third class lever. Okay, this is the third class lever. The second class lever. It's like nutcracker. So here, by a very small push here, we can breaking the nut, which we can't break it with our hand. You can't catch the nut and break it with your hand, of course not. But by using this nutcracker, by making a small effort from this side, we can get a huge effort or a huge resistance by crushing the nut. So this is a very, very important part, which is types of lever. We have 3 classes, first and second and third. The first class, sometimes save effort. Sometimes save effort when the effort force arm longer than resistance arm. Yes, in the second class lever, it always saving effort because it always have force arm longer than resistance arm. And third class lever, it always doesn't save effort because always has the resistance arm longer than force arm. And by this talking, it will be the end of our lessons number 2, and I need you to study hard, and if there are anything difficult, we can contact with each other on this site. Thanks.